Welcome to Pure One, Chapter 11.6. After 11.5, where we do vector proof. If you haven't watched that yet, make sure you go to do that because that's where we became a BFF. But not anymore because we have a new lesson and we're now strangers. And you got to listen to a stranger to teach you maths. Right, because if it's not a stranger, it's your parents, you're gonna cry when when your parents teach you maths. That's what my parents did to me when I was a kid. Somehow I heard many stories of students, of children having similar experience when they was a kid. Parents teach them maths, or usually dad or father. Yeah, you're crying a lot. Anyway, modeling factors. So a car is moving with velocity 6i plus 12j kilometers per hour from the origin. Find the speed of the car. So the difference between velocity and speed, if you don't know, okay, um, velocity has direction 6i plus 12j. So velocity is a vector, okay, where speed is a scalar. So what's the scalar? The difference. Essentially, velocity equals, okay, actually not. It's a magnitude of velocity equals speed. Or the other way around, I should write speed equals to the magnitude of velocity. We mentioned about how to find the magnitude. To find the magnitude, you do square root of the 6 squared plus 12 squared. Essentially, it's the size, the distance, something similar. So square root, put that in the calculator, you should get 13.4 kilometers per hour. Oh, no, not like this, per hour. And that's the answer. That's the speed. Okay, yay. Next. Example, I start from O and walk 15 kilometers. So let's draw a diagram. Okay, so O. Okay, I walk 15 kilometers on a bearing 120 degree to A. So to draw bearing, okay, you can draw an arrow, okay, up, which is the north line. 120 degree, that's 90, so 120 somewhere there. Okay, to A. And what I know is that this is 15 kilometers. Then I walk 9 kilometers on a bearing of 240 degree to B. So next I need to draw again a north line from A. 240 degree. Oops. 240 degree from A. So that's 180. 240 must be somewhere there. Right? And that's 9 kilometers. And I know this is, okay, I'm going to rub off A because, so the point A is there. So I know this 240 degree. Okay. Next, then I return from B directly to O. That's perfectly fine. Okay, so you can imagine already see a triangle in there. So you should be thinking of something to do with sine rule, cosine rule, perhaps, most likely. So find a position vector of A relative to O. So we want to find OA. Okay, to find OA, so question A. To find OA, we can let it be xi plus yj. So where's the x and y? Well, we can do it in here if we draw a triangle from O to A, that's your X, that's your Y. Okay, so we want to find the X and Y. So what do we know so far? Well, if I draw a triangle in here, you can see, probably help you see better. That's your angle, that's your X, and that's your Y. Now, I know this angle is 30 degree. Is it 30? Because that's a angle, that must be 30 degree. 30 degree, and that's 15 kilometers. That's enough to find X and Y using Pythagoras. I know Pythagoras, Sokotoa. So so cos 30 degree equals x over 15. So x equals 15 cos 30 degree. Put in the calculator, you should get, I just round to 13. And for y, sine 30 degree equals y over 15. So y equals 15 sine 30, which is a half of 15, which is 7.5. So therefore, OA equals to 13i minus 7.5j. Now, it's negative because y going downwards. Okay, so hopefully it should be quite self-explanatory. We're going into bottom right corner direction, so x to right, y downwards. So now why not y upwards, x to left? Because O to A. So O to right, y downwards. Okay, that's the answer. Part B, to find OB. To find OB, the magnitude of OB, let's find a vector OB first. Why not? Okay, so let's find a vector OB. So if we can find a vector OB, distance OB, or Now this does not seem to be too much with the vector in here, even this vector. Maybe I will think about the distance OB. So OB, let me think. So OB is the distance of OB. The quicker way is probably I'm thinking about cosine rule. Yeah, 15. So what else do I know? What angle do I know? If I know that's 30 degree, that's a 90 degree, 90, 120, that must be 60. If that's 60, this must be 60, 300, that must also be 60 degree. Okay, so I can probably use cosine rule. So let me draw a triangle out again, just for reference. So that's O. Actually, it should be here. Yep. So that's O, B, A. This is 60 degree. This is 15. This is 9. So I want to find X. I want to find question mark. OB. Easy. So cosine rule. Okay, so cosine rule. Um, Bracket cosine rule, just to make you aware. So that with my A. So A squared equals B squared plus C squared minus 2BC cos A. The reason I write the formula is that it's so that it just lessen my cognitive load. That means I don't have to use as much cognitively when I substitute in. It just do less things, okay, at one step. You don't have to recall and try to substitute in together. You just have to substitute, do less things in your brain. So A is unknown, so A squared equals B squared. 15 squared plus 9 squared minus 2 times 15 times 9 cos 60 degree. Put in the calculator, you should get A squared equals 171. So A equals 13.1 kilometers, which is essentially your distance of OB. So OB equals 13.1 kilometers. Okay, right, part C. So how do we find part C? So let's have a look, part C. Find the bearing from O to B. So maybe this time I'll just do it here. Might be easier. So now I know this 13.1. Part C. Find a bearing from O to B. From O to B. That means the angle should be measured from O. So I want to measure this. So the bearing is the whole thing here. So rather than work out this whole thing, I know it's 120, so I can work out theta. So to work out theta, we know 13.1, we can use sine rule. So sine rule. Sine rule. So 9 over, or actually sine theta over 9 equals 13.1 over sine 60. Easy peasy. So sine theta equals 13.1 over sine 60 degree. Times it by 9. So theta equals inverse sine the whole thing. Put in a calculator. You should get 36.6 degree. Therefore, the bearing from O to B is 120 plus 36 point. If I round it, just round to two significant figure, that will give me 157 degree. And that's the bearing. All right, 3 digits. Part D, find the position vector of B relative to O. That means they want you to find OB. So they want you to find OB. So part D. So to find OB. To find OB, we can use the vector here. We can use triangle here. Let me do this again. Yep. Okay. So this triangle, that's Y and that's X. So if you allow me to draw a triangle in here, go really long straight. So O to B. So O to B. O to B. I know that's 13.1 and I know this is Y and this is X. Now missing some angle in here. So what you should know is that Y is perpendicular downwards to N. Not perpendicular downwards, it's in straight line downwards. That means that's a straight line. If that's a straight line, the angle here would be 180 degree minus 157 degree, which is mental math 23 degree. So there we go. Trigonometry again. Okay, so that's your angle. X and Y are always perpendicular to each other. So X is sine this time. So sine 23 degree equals X over 13.1. So X equals 13.1 sine 23 degree, which is 12, no, 12, 5.11. Oh, by the way, I think I used root 171 instead, which is probably a better number. And y equals to root 171 cos 23, which is 12. Therefore, O to B equals to, now x goes first to the right, so x positive 5.11i, y is downwards, so minus 12j. Right? So after hearing me waffling, your turn to waffle, okay, correctly. So have a go, place question one, okay, draw a diagram to help you, okay. When you're ready for the answer, you can press play. So here are the answers, A, B, C, D. Okay, if you got them all right, move on. Well done. But if you don't, I'm gonna go through. Okay. Question eight: the girl walks 2 kilometers due east, so that's due east 2 kilometers from a fixed point O to A. Okay. Next, she then walks 3 kilometers south. So in here, that's due B. So 3 kilometers. Okay. Find the total distance traveled. Well, she walked 2 to the A and 3 to the B. Obviously, 2 plus 3 is 5. Part A done. Okay. Part B, find the position vector of B relative to O. So we'll find OB. Okay. So part B, we'll find OB. To find OB, we can do OA plus AB. Well, OA is to right, so 2I. AB is going down 3J. Part C, to find the magnitude of OB, you've done this quite a lot. 2 squared plus negative 3 squared. We know negative is not really necessary. So 2 squared plus 3 squared and square root will be square root of 13, which is 3.61 kilometers. And D, find the bearing of B from O. So from O means you want to draw a north line upwards to find this a bearing. We know that's 90 degree. So all I need to do is to find this theta. So tan theta equals to 3 over 2. Theta equals inverse 10 of 3 over 2, which is 56.3 degree. So the bearing, therefore, the bearing is 90 degree plus 56.3 degree, but we should just write 3 digits, so 146 degree. That's the answer. All right. Practice question two. Okay, pause the video. By the way, if you forgot what is a resultant force means E plus F. Okay, so just add the vectors together. Parallel. We mentioned this parallel before, so see if you remember. I think it's 11.3 or 11.2. Can't remember exactly which one. So go back to the video and have a look. Pause the video, have a go. When you're ready for the answer, you can press play. So part A, find the angle between R and the vector I. I is a x-axis. So let's have a look. Now A, what do we know about R? Well, we're told R is E plus F. E is 3I minus 4J plus F, PI plus QJ. Now I mentioned this quite a few times. When you see multiple I's or more than one I, you want to group them up together, factorize it. In the final expression, there should only be one I and one J. Okay. But in here, if you want to try and find a vector, it's quite difficult because we don't know what P and Q is. Therefore, you'll be thinking, oh, that might not be the way to go. So it acts in direction parallel to 2I minus J. So that means R is actually parallel to 2I minus J. So on a side note, R is parallel to 2I minus J. That means if I want to find the angle of R with I can use 2I minus J. Why? Because 2I minus J is 2 to right, 1 down. So that's 2I minus J. Okay, so that's 2I minus J. So I'm working the vector here. Now imagine I told you R is parallel to this line. So I can draw another line that's parallel to this. Okay, I want to draw another line parallel to the blue line in here. You can see it's parallel, right? The angle that is parallel to I, okay, will be here. Which using parallel angle, these two angles are the same. Or if you try to bring theta bring the line to different way around, okay, you can then draw a line. That's the same with theta. So when the two lines are parallel, you can use the other one to work out the angle between I. So if you don't understand, you can always ask me. Leave a comment below. Right, so to leave theta, okay, to work out theta. So theta is, so I know that's 2 and that's 1. So tan theta equals to 1 over 2. Okay, just draw the triangle out for you. Here, that angle to 1 theta. So theta equals inverse 10 of a half, which is 26.6 degree. Oh, by the way, below horizontal. We must write below horizontal. Why? Because the other angle could be upwards, could be above the horizontal, but this below the horizontal. Well, yeah. Puppy. Show that p plus 2q equals 5. That's when we can use the word parallel. Parallel also means the gradient is the same. Okay, so the gradient m of r equals, remember it's a j component over the I component, so minus 4 plus q over 3 plus p. The gradient of 2i minus j is minus 1 over 2. The j component over the I component, minus 1 over 2. So they're parallel, means they're equal. So minus 4 plus q over 3 plus p equals to minus a half. I multiply minus 2 over, so minus 2 times minus 4 plus q equals 1 times 3 plus p. Cross multiply. Expand bracket. 8 minus 2q equals 3 plus p. So bring the p and q on one side. So bring q on the right hand side. Keep the constant left hand side. So bring the 3 left to the left. 5 equals p plus 2q, which is the same as the question. Part C, given p equals 1, find magnitude of r. Well, easy peasy. If I know p is 1, so sub p equals 1. So if I know p is 1, then 5 equals 1 plus 2q, q equals to 2. Therefore, r equals, so if I know p and q now, so r equals to 3 plus pi, 3 plus 1i, plus minus 4 plus 2j. So r equals to 4i minus 2j. And to find magnitude, square root of 4 squared plus 2 squared. Well, the minus doesn't matter because when you square root, it doesn't matter. So 16 plus 2 squared, which indeed is, put in calculator, 2 root 5. And that's the end of the vector chapter. Quite a long one at the end, I know.